So, although I'm not in a hurry today, I will maybe better start. Again, as before, please interrupt me as much as possible. Whenever you find something obscure or unclear or patently false, just tell me. Want to just have a few comments on some further topics. There's a lot of materials I didn't deal with and that has been published. For example, you could worry whether you have static proofs as you have for Tarski logics. So what that means is that if you write down the lines, you never mark anything or come back on any conclusion drawn. Whatever has been derived at some point remains derived forever. That's related to the monotonicity and some other properties of the logic. But in the case of adaptive logic, we have these dynamic proofs where lines are marked or unmarked. And then there was the game theoretic reading of that in terms of a proponent and an opponent. And you may wonder whether it is possible, whether these adaptive logic proofs or dynamic proofs, whether this is the full notion of dynamic proof. And actually it is not, but this has been studied already and was published. There is a general idea of what is a proof dynamic, what does that mean? And that notion is, of course, much broader than what we have in adaptive logics, but the thing was published. On the other hand, there are still some open problems, like you wonder, can we generalize the notion of a strategy or define the notion of a strategy in such a way that we get an idea of what possible strategies might come up in the future. So this has not been studied and hence not either published. I go from down, slowly going up. So this was the last line. The previous line refers to theories, although the idea was always for adaptive logics that there should be a problem somewhere and then the logic should react on that, like eliminate inconsistencies or go further than think about ampliative adaptive logics, get to inductive generalization, which of course classical predicate logic does not give us. But so you have a problem. See, I want to accept certain generalizations that transcend the classical consequences. How can I get there? And then you move to an adaptive logic. So the basic idea is that the intention of working on adaptive logic was to get a hand on or get an insight on methods and methodologies. But it turned out later that it was also interesting to use adaptive logics as the underlying logic of a theory. So theory is traditionally defined, or just, I think it's even an idea that was in Tarski, and certainly Da Costa has explorated and written about this idea that you consider a theory as a couple. You have a logic, and then you have a set of non-logical axioms, gamma. And the theorems of the theory, of course, are the consequence set of gamma in terms of the logic L. So whatever follows from gamma by a logic L are theorems, non-logical theorems of the theory. You can apply this to physics or to whatever you wish. And then, so of course now the theory has, on the one hand, is a couple, that's a technical thing, and the other hand, it's simply a set of consequences. by our consequences of the non-logical premises. Okay? So now what happens if you replace this, here is usually defined for a tasky logic, if you replace it with an adaptive logic, this makes sense in a number of cases. And if you want an example, of course, I refer to my Studia Lógica paper of 2022, last year. Actually, the online version was published already in 21. So that gives you, takes the Fregean axioms, extensionality and abstraction, and then defines in an adaptive way a theory from that. I think that's a good example. Of course, it was not the first example, it's something rather complex, as you may imagine. Okay, so then we go to the previous 10 combinations of adaptive logics. Especially if you try to get some sight on creativity or on means to apply scientific reasoning in a way that relates to creativity, then you will very often try to apply a sequence of adaptive logics. For example, you will say, you have something to explain, you will say, can I derive it from a given theory, from a theory that is available? If not, maybe you need some more, if you need another theories, then you may try to go to something like inductive generalization in the first place. That's of course a very simple case, just generalizing from data, staying within the same conceptual frame. It's more interesting if you get to a different conceptual frame. This has not been worked out yet. But then you might, as a simple step, if you do not find an explanation from the available theories, you may move to generalize and then find new theories, but within given conceptual systems, and then from there move on and apply again what the new theory you found, apply them again to have a better explanation for some or other explanatory question. So the idea of superposing adaptive logics is rather natural, one on top of the other. There is also the notion of prioritized adaptive logics. You may, in some cases, say I want to, well, the intuitive idea is just like prioritized logics in general, namely that there are certain things you take to be, you want to add them to your consequence set, but you add them in a certain order. So there's a lot of work on this by French philosopher, not philosopher, but French mathematician and computer scientists, especially people like Van Ferrat and a number of others. So you can try to integrate it in the system here. So then the idea is to superpose, like you could have some things that you consider to be true and that you just write with a formula like P or P and Q. And then you could have other data that you consider as a bit, well, as likely to be true, but not just plainly true. And then you could express that this is a simple model. You could express that by adding a possibility operator in front of it. And that would mean this is, well, you do not read it down as possible, but it's likely to be true. So if there is a formula, if you have P, for example, and then you have likely not P, then the likely not P will not be able to add anything to P, because otherwise you get inconsistency. You will start here at the first level, take P, and then at the next level, you will not add not P. If you have also likely in Q, there is no problem to add that. So then you can put an index here, you can have like, well, think about 2 of these diamonds, or 3 or 4 or 5, would say the higher I is, the higher number of diamonds you have there, or losanges, as some people like to call it, the less likely it is that this thing is true. Okay, so in this way you can handle the work by this Frenchman and somebody. You had a mathematician in Ghent that wanted to get an MA, a doctorate, a PhD in philosophy, because she wanted to get closer to how people think and not she wanted to get away from mathematics. She had for 4 years the highest distinction, but nevertheless wanted to get closer to the way ordinary people think and not stay in mathematics. So then that's how she came to me. And there is papers of her are on the web. Her name is Lisa Verhoeven. Funny thing is that now first names are rather, first name is understandable in every language, I think. If you get to the last name, most people get lost. Okay. So you handle this as a combined adaptive logic simply. Namely, you first apply the classical consequences and then you apply consequences of this level, namely if you can consistently add to your conclusions or to the conclusion set, you can add something that is not given to be true, but likely to be true, is level 1 here, then you will do that, and then you move to level 2, and so on. The idea is very simple. Okay, so this phenomenon, although there has been a PhD on it, which you also can find on the net, the thing is not completely under control at the moment. And is not completely studied from a theoretical point of view. There are a number of tricks, how to handle it, how to construct proofs, but it is not fully studied. There was a PhD by a man that is now a professor in Rotterdam University, Frederik van der Putten is his name. Again, an easy first name and then a difficult last name for non-Dutch speaking people. Fortunately, in Rotterdam, they still speak Dutch.
Before you go on, can I backtrack and ask you a question? There was your definition of theory, and you gave a standard story, and you said that you can replace the deductive relation with an adaptive relation.
Yes.
But you said you can do it, it makes sense sometimes. That surprised me.
You can do it.
You said you can do it, it makes sense sometimes. And I expect you to say you can always do it. I wasn't sure what reservations you had.
Oh, the reservation was, I think, philosophical. So the two things I tried to work out was, on the one hand, consider piano arithmetic and add an inconsistency, like some number is different from itself, or some number is its own successor. So that means you could, in that indirect way, study what would happen if tomorrow or the day after tomorrow somebody discovers that there is a number, you can derive from piano arithmetic that there is a number that is actually its own successor. So if you add it explicitly as an axiom, then you can see what follows from that. The other example is the Frege set theory, adaptive set theory. But I think, well, it does not make sense to just take, for example, there's no reason to take contemporary or to take Newtonian physics and add an adaptive logic as an underlying logic. That will not give you anything physically interesting, I suppose.
Okay. Yeah.
So you need to have a reason to want an adaptive logic underlying there.
Okay. I take that point, but I just thought you were saying. I thought you were talking about what you could do theoretically or formally, and I thought what you were describing you could always do theoretically. It's going to give you a perfectly good theory, but of course it might not be a very interesting one.
Yeah, I mean, that's more accurate, yes. Yeah. Okay, so especially interesting for these combinations is, does that raise the complexity of, if you have a combination of adaptive logics, does it raise the complexity of the consequence set, the combined consequence set, or not? This is completely unknown at the moment. But I think that if I talk, there are some Russians now in the mathematics department, in the logic group of the mathematics department in Ghent, and I'm going to talk to them, I think, and try to get their interest. It's also basically Sergei Odintsov and one of his students, that Stanislav, and then I'm very bad at remembering names. Sorry, I had too many students in my life. I was making a quick calculation yesterday, and I must have had some 50,000 students at the very least. I mean, this includes huge courses that you teach, like 600 students from physics, the Faculty of Sciences and things like that. I was especially terrorized by faculties of psychology and political science. Okay. Of course, these are very smart students, but nevertheless, 600 is a bit much. Good. So I hope that these two Russians that are now in the logic department of the science faculty will be able to help me if I explain them clearly what is the problem, to calculate, to decide what is the complexity. I told you that for adaptive logics, for reliability it is simpler, but for minimal abnormality it goes up to pi1. That's very complex. And it would be nice if the complexity is not raised by combining different such adaptive logics one on top of the other. But I'm not sure. And then there is the problem of devising simply new adaptive logics. And well, you need to have a problem. There need to be a phenomenon for which you want to have an adaptive logic before you can show that. But fortunately, talking to Eduardo, I think the day before yesterday, he asked me whether I could do an adaptive approach about maximality. Well, there isn't one, but it is very easy. So between the lunch and coming here, I made some notes, and it's not too difficult to create one. So suppose you have a quantitative predicate, like think about length simply. So some people have a certain length, and then you want to say the lowest student in this class. Okay, you want to pick out a maximum there. So how you will see that it's very simple to approach this. What you want is, first of all, you have these properties that you can express by things like qi, and the index indicates the length. So the higher I is, the higher the length of this person. And then you can say, what does it mean that somebody is the lowest one? So what is the maximum? We could introduce a predicate like and Q, the maximum in Q, and you could define, I think it is better first to introduce some comparative things like X. This would mean X has a higher value than Y with respect to Q. Okay? And then you could define the maximum as for all Y. So X is a maximal, Q maximal entity would mean for all I, X is still with respect to Q larger than Y. Okay, then X is a maximum. So that's very simple. Now you have, of course, either this X is maximal with respect to Q, or there is a Y such that Y is larger than X. That's simply excluded middle. If you look at the definition of MQ, so you can write down that at every, since it excluded middle is a theorem, you can write down that at every line. It's a logical truth. And then, if you declare these things to be abnormalities, you can push them in the condition. So that means you consider the condition as false unless and until you have found that the conclusion is derivable from your premise. So it's a kind of simplistic approach. What you do is you suppose that the normal case is that an object is maximal with respect to length, which is like philosophically not extremely attractive, but it gives you a simple way to approach the thing. You can also do it the other way around. But you say, well, from the fact that some person has a certain length, I can derive either this person has a maximal length in the group, or there is a person in the group that is longer. Okay, that's the idea. And the last thing you declare as an abnormality. So it's completely arbitrary, these abnormalities. And that's something that Walter Carnielli pointed out to me a long time ago. In the beginning, I sometimes presented the approach as if the notion of an abnormality was like a logical problem. And that's because the oldest case was handling inconsistency. And you can easily, most classical logicians will see inconsistencies as problems, and actually Hegel also sees it as a problem, of course, because it causes dynamics. So, but here you see that for applications like this, especially, you pick one of two possible approaches. Is what I did. I took it to be the normal case is that something is maximal with respect to length. So a normal student is one that is the longest of the class. Okay, but that's arbitrary. You can also take the opposite and say this is normal and that thing is the abnormality. That will actually give you the same result after some calculations. Yeah, I think that's so. I just wanted to illustrate how simple it is to devise an adaptive logic that catches a notion, and I took this notion that Eduardo put in my nose 2 days ago. Okay. Is there? Okay, I think I said what was there. There's one other thing I would like to show you because I forgot to do it yesterday. Namely, if you look at a dynamic proof, what you have is a line number, let's say I1, and then a formula, say A1, and then a justification, G1, and then you have a set of abnormalities, the condition. Call it delta 1. And it goes on like that to IN, an, gn, and delta n. Okay, so this is this dynamic proof with conditions on it and justifications that are slightly more complex than in the task. Now you can very easily translate this to a static proof. So let's take again handling inconsistency as an example. So let this be that the logic clone be the lower limit logic. And so this will be clone R or clone M, reliability or minimal abnormality applied to clone. Now you can, this dynamic proof you can transcribe as a static proof. And then in the metatheory prove the following thing. The transcription will actually be like I1. The line numbers will simply remain, and then the formula you transform. You write A1 or classical disjunction, that disjunction of abnormalities, classical disjunction of abnormalities, delta 1. And to do that for all your steps. N or delta n. So now you can, it's not very difficult to show that this proof is correct, this dynamic proof is correct, just in case this static proof, which is simply in clone, it's a proof in clone, just in case that is correct. And the other way around, you can transform it in both directions. And all you have to do, the proof is very simple, because all you have to do is that if, as long as here you apply in this justification, you apply the unconditional rule, the generic unconditional rule that we have seen 2 years ago, then it will just remain the same here. If you apply the conditional rule, that means that something is added to the delta, and then you can show that this conditional. I'll show you the rules, and then you will see why this. Almost there. Don't worry. So what happens if you apply the conditional rule, the lowest one, then here B or classical disjunction of abnormalities, finite set of abnormalities theta. So now suppose you read this and you apply the conditional rule just to the same case. What does that give us? That gives us B. No, I need it. We'll start more. So maybe I use a blackboard over here. And from these things follow B or theta. So now you can either apply the conditional rule, and that means that you write down B and then write down here delta 1 union up to delta n union theta. But of course you can also simply apply the unconditional rule, and that means that you leave the dot theta here and you don't have to add then this theta on this side. You don't have to push it to the condition. So that means you can continue only applying the unconditional rule, which means that you are writing a clone proof simply, So a proof in the tasky logic clun, this thing. And then at the very last step, you will push all the abnormalities to the condition, all at once as one cell. Comes to exactly the same thing. You can show that it works in both directions, transforming this to that or this to that. In other words, you can think about an adaptive logic as simply applying the lower limit logic, and then in the end taking out the abnormalities and pushing them to the condition. And the rest, what remains, the other disjuncts that remain, will be the formula that you then have adaptively derived. Is the idea clear? Thanks. I think that's a useful insight because it simplifies the whole thing. And nobody should be afraid of, nobody is afraid of tasky proofs, right? So there's nothing so special or so new in adaptive logic. But for me, the notion of a proof is very important, and that's one of the problems I have with Graham's LPM. Graham does not have a proof theory for his LPM. So I was saying something about him and apologized because he was not present like 2 days ago, but now he is present. So and, I feel comfortable to say that. Because the proof theory of the adaptive logic, the dynamic proof, has the advantage that I've published on that it explicates, not explains, but explicates. This comes from Carnap, explicate. It explicates the idea of the reasoning that we perform to get to the adaptive consequences. You can show that there's a correspondence, or that you can explicate the dynamics that happens in the feasible reasoning form that you can characterize by adaptive logic. This dynamics is quoted by the dynamic proof. I think that's what is interesting of the dynamic proof. It's not just something technical. It gets you to the point where you say, aha, and now I found out that something is derived, but I didn't know it here yet, and this line has to be marked, for example. So that's the growing, you can express the growing insight in the premises in terms of your proof. Good.
So can I make a comment on that?
Sure, I was, that's why I said it, of course.
I don't know if LPM has a proof theory. I've never investigated that.
But you have published it. It's not a Hilbertian proof theory, but it's definitely a kind of Fitch-type proof theory. There is one for LP.
No, I'm talking about LPM.
Yeah, okay, well.
I mean, you said you didn't like LPM.
No, I don't think there is one. You're right, I don't think there is one for LPM. But of course, if you apply one of my strategies to LP, then there is a proof theory.
No, I agree with that, and that's nice. I mean, whether LPM itself has a proof theory, I just don't know. I've never thought about it. I've always been more interested in non-theoretic notion. And if it's got a proof theory, that's fine. You know, I don't have a problem with that. But I just wanted to ask a question about J.C. Fields, because he has said things which are more sort of hostile to the idea. So take RC, right? JC is
RC, the conditional rule, yes?
JC is adopting the word deductivist, and he said that all you can ever get in a paraconsistent context is something like RC. You get you get the consequent plus a string of disjuncts, usually which are contradictory. And he says that after that, this is not logic. After that, It's just a matter of rational judgment about which of the disjuncts you're choosing when you ignore some of the contradictory disjuncts. I don't agree with him, but this is his view. Okay, so he's a better target for what you want, I think.
Yeah. Yeah, I've seen these claims by GC and I don't agree with it, of course, because what is logic? I think the general definition of logic is it is a relation between premise sets and consequence sets. So you can see logic as a function that maps to every premise set of a certain language a consequence set in that language. And that's definitely what adaptive logics do. Because you can show, think again about proving variance and those things I mentioned before, you can show that for every premise set there is precisely one consequence set. It does not depend on how you proceed or whatever, there just is one consequence set.
I agree with that. I mean, let me just sort of play devil's advocate and say what JC would say here. Certainly there's more to reasoning than consequence. So, if you find your premise entails something or other and you don't like it, you've got a choice. Either you accept the thing you don't like or you get rid of some of the things that got you there, right? And that is not in the domain of, that's in the domain of belief revision, not the domain of consequence. So he says that, well, there's got to be more to rationality or reasoning than simply consequence. And I'm pretty sure he'd say that once you've got one of these disjunctive consequences as an RC, it's the same. It's not something that logic can give you. Thereafter, it's a matter of, and then you tell some kind of story about rationality to say which of the disjuncts you like and which ones you don't.
But my problem with GC's position is that, even as you state now, I think it's quite accurate. Of course, there is a difference between adaptive logics and tasky logics. Tasky logics explicate the notion of deductive consequence. So this says something about retaining the meaning of the consequences is included in the meaning of the premises and things like that can apply to that. Adaptive logics are very different from that. They refer to methods. So they are not about retaining truth or meaning or whatever. They are about characterizing methods. And of course, if you characterize a method that does not come to a tasky logic in the first place. So if you characterize such a method, then you do something else than what is done in tasky logics or in deductive logics. So now that the question is, do we still use the general name for assigning consequence sets to premise sets, or do we want another name? I have at some point proposed the name G-close instead of logics. If some people want to call it G-close, that's okay for me. The name is not important, but the underlying idea is important. And so I think GC cannot deny that if you can apply a method in a systematic way, that means a way that does not have arbitrary or other funny properties. For example, it has proven variance and those properties, then I think there's kind of natural concepts to say a function that assigns to a premise set, to every premise set a consequence set from a certain language.
No, I agree with you. I mean,
You were just, yeah, you were, I know.
For advocating a non-monotonic logic. And I just think he's crazy.
Good. Any other questions at the moment? Or was it all too clear? My regular students always complained that it was very clear when I talked about it in the class, but when they had later to study it, it was less clear, they claim. That simply means that I talk better than that I write. So no more questions? Is that correct? Everybody convinced? There is also when you go to my homepage, there is the first point where you get is this address at Ghent University users. And then you have a list of things that is displayed. One is my CV, where you find, of course, references to my publications, and many publications are simply there, either the publication itself or the last preprint before the final corrections or a postprint sometimes. But you also find some other things, like I shall put the slides in that place, then you can easily get it. If you are interested, you can download them from there. But there is also a kind of bibliography of adaptive logics. Of course, you have my bibliography, and the papers that I wrote on adaptive logics are in there. But there are a lot of other people that work. I mentioned it a few days ago. I had something like 16 PhD students working on adaptive logics. So it's good to have a kind of common bibliography. And I put it on that website, you will find it. It is called something like a survey of adaptive logics, I think, and then it has all the references to the papers that I retraced until now. But I should ask other people to add more things to it also. Yeah, please.
So, I was thinking in one of your previous classes about your notion of final derivability. And I have a kind of an objection to it. I don't know the nature of the objection, perhaps it's just aesthetic, but the thing is, it seems to me to be a kind of a meta definition. You're saying that some formula or some conclusion is warranted when a certain meta-theoretical property holds, which is some assertion about a collection of proofs, and that seems, I don't know, it's unjustified, a kind of it leads me to believe that adaptive logics are not well suited to work as deductive logics. That's not the point.
Yeah, of course they are not deductive logics, yes.
I mean, even that notion, okay, it works somehow, but the thing is, perhaps it's more interesting to understand the inner dynamics, as, for example, if some proposition or some line could be flipped over and over between Martin and Mark, that's a problem, because you don't stabilize your notion internally, even though meta-theoretically you might.
Yeah. So if it is finally derivable, there is a proof, it may be transfinite, where it stabilizes. You can show that. So,
okay. And is there any result about in what conditions does that hold for finite proofs?
I think there's no specific statement was ever proven about that. I stumbled upon the problem when I was making the transgression from propositional logic to predicative logic. This happened in the paper I've mentioned it, that was edited by Eva Orłowska from Warsaw. And it was in this book in the memory of Elena Rasiova. So then I found that in some cases I needed even to, this is worse than what you complain about. In some cases you need to allow for, I told you this idea, that you have a finite proof, and then if you can extend it in such a way that a certain line is marked in it, then the proponent can further extend it in such a way that that line will be non-marked again, or unmarked in correct English. Although unmarked sounds like that somebody does something. It sounds like describing an action, but it does not. So, Graham is a native speaker and there will be more native speakers of English. So unmarked is simply can be used as a predicate, not referring to any action of a person. But then, so in some cases you have to allow for these extensions to be infinite, because otherwise because you have this phenomenon that you may go on forever, marking, unmarking, if you do it stepwise. So that if you can do it with an infinite extension, you solve that problem. Is that objectionable? I don't know. I think not. I mean, I rather consider it, well, you have these logics here, and now they turn out to have that property. So what? Yeah. So the fact that, when Gödel's theorem was proved, I think this was proven, this is like, we discovered a property of piano arithmetic. Of course, Graham will not completely agree to that because he will say that there is the alternative of piano arithmetic being inconsistent. But as the way in which Gödel proceeded and the framework within he was working, there it is an insight that is gained, namely that you cannot rule out non-standard models as a way to translate it, right? Or alien intruders, as Bob Meyer used to call it.
I know it's already established, but perhaps you could call the marked line as impeded and unimpeded, so it doesn't seem like an action.
Yeah.
Can I just pursue the point? Because there is an interesting point here, I think. With this notion of final derivability, you get the monotheoretic consequence, which is stable and well-defined. It's the things you get when you're doing proof theory, which are not stable in that way. Okay. Now that raises an interesting question, which is this. Suppose that you and I have this system, and you're sort of doing some dynamic proof theory, and I'm doing some dynamic proof theory. We make choices as we go along, and you and I may make different choices.
Yeah.
So at any stage, we're going to get very different results depending on the choices we make. And that's a fact of the logic. I mean, I agree with that, that's just a fact. But it raises a kind of interesting methodological issue of what happens when you've taken one path of deduction, I've taken another path, we've got different results. What do you do in that situation?
I have a meta theorem that says that you don't get different results by taking different paths. That's the proven.
Eventually, but because we're never at the end eventually, we're only partially there in most cases. So, I mean, we can't wait forever. What do we do when we get this real-time disagreement?
Well, I would rather prefer to think about it for a while than to answer straightforwardly. But my intuition is to be rather convinced that it does not cause a real problem. But I cannot just, since my sleeve is too small, if I would have a longer one, I would pull a better argument out of my sleeve, but no, I can't. Yeah. Anyway, thanks for the question, Graham. I'll think about it.
Yeah, I mean, that's one reason why I've always liked a lot of great definitions, because it doesn't pose this problem.
You've always,
That's the reason why I've always liked a lot of theory definition, what you call ultimate derivability.
yeah.
And I've never really known how to address the question I've just asked you.
So the fact that there is a transfinite proof is for you more convincing. That there is a stable transfinite proof that characterizes final derivability.
The ultimate derivability on the model, what the model direct definition gives you is unique and determinate. Okay, that's nice. But if you're looking at these things proof theoretically, you have to think of them as dynamically evolving entities.
Yeah.
And that's interesting. We do work like that, for sure. But it does pose the problem of the methodological problem of what happens when you and I have made different choices and reached different results.
But well, what you can prove is that if I continue your proof, I can add all my stuff, and if you continue my proof, you can add all the things you derived finally. You can also obtain them in my proof. I think that is at least to some extent a consolation.
That's true.
We can, after some work, agree. That's what you're saying.
And also the fact that, well, there is a relation. Oh, sorry, I lost it now. Okay. More questions? Apparently not. So the people of the organization should take a decision now. You put me off the hook. Is it okay? Did I do enough or should I continue talking? I could declamate some poems in Dutch.